Hi guys, this is the fourth segment of chapter 2 in historical geology. We just finished all the sedimentary rocks and sedimentaries, all of that, and we're gonna start talking about the stratigraphy. So this part is brand new for you. Um, Stratigraphy is the branch of geology that works with the composition, origin, age, relationships, and the areal extent of layered or stratified rocks. Um, Stratification can occur in every rock, as I mentioned, every type of rocks, but uh, all the sedimentary rocks are stratified. So as I already mentioned, those are the rocks we use most of the time in historical geology. So we have to talk about the vertical stratigraphic relationship. That is how the different layers follow each other. Basically, the bounding surfaces are the ones which are separating the layers from each other. And this is what we call bedding plane. The bedding plane can be gradational, which means the one rock is gradually changing into another one, or it could be sharp. When it's sharp, that would just means that the rocks below the bedding surface or bedding plane, below and above, is different. It means different environment. Something had to be changing. Either it went into ocean from a continent. Sometimes it can mean a whole lot of time missing from the succession. Now, if you look at the lateral relationship in between if you're not going vertically but laterally, then that could be important things you have to know about. Like if you remember, one of the geologic principle was the lateral continuity. That just means that if you have a sedimentary basin, the sediment will fill up the basin all the way to the edge of the basin. Now, sometimes it's not necessarily the edge of the basin. Sometimes what could have happened that later there was a big fault line which actually abruptly finished those layers off. So here, that's the normal regular edge of the basin situation, and this one is where the certain sedimentary layers are just truncated by a fault line. And if we go further, it could be that the boundary between two rocks sideways, I mean horizontally, um, could be related to environmental changes, like small environmental changes, like right here. It just means that this area has been in deeper water, producing a certain type of rocks, but as you go through time, the environment has changed, so another type of rock has formed, and so we call it pinching out. Sometimes the environment changes more frequently, just like you see it here, and therefore this boundary between the two kinds of rock could be like really zigzag, and we call that intertongue. It's a funny word, so don't laugh. It's intertonguing. It's called intertonguing. And then sometimes it can just gradually change from one to the other horizontally. And on this side, you can see actually a intertonguing right here. So one rock changed into another horizontally because of environmental change. Um, Both intertonguing and lateral gradation indicates simultaneous. That means that the deposition of these two kinds of rock happened at the same time in adjacent environments. So therefore, this takes us to the so-called sedimentary facies. Sedimentary facies is a body of sediment with distinctive physical, chemical, and biological attributes. Like it has certain type of fossils, it has certain type of composition, and it represents a certain type physical condition. And therefore, they can be side by side with other sediments which are formed in somewhat different environment. So this shows you an area, like let's say on a beach, where you can actually see the sedimentary facies next to each other. So right here, that's the supratidal. I mean, it's always above sea level. This is the zone when you got the rivers and everything. So that's a certain sedimentary environment. And then if you go to the very shallow water, remember that's where you have all the waves. So it's very high energy environment, and it will produce a certain type of sediment. And if you go to deeper water, it's gonna produce another type of sediment. And if it's even more deep water, then it's gonna be different. So this is how the sedimentary facies can exist next to each other and produce sediment which forms exactly at the same time. And this takes us to the sea level changes. You know, what happens with these sedimentary facies as the sea level is changing? And it's very interesting. You got to understand sea level has been changing since continents have formed. Sea level is going up and down for different reasons. So therefore, we have to learn about what happens with the sedimentary facies as the sea level is changing. We have two end members. One is when the sea level is going up, and we call that transgression. And the other one is when the sea level is going down, and this is what we call regression. So we have transgression and we have regression. When you have transgression, the sea level is going up. That means, what does that mean? What happens with the continent when the sea level is going up? Yeah, you're right. More and more land is going to be covered by water. So that means that the continent is shrinking, becomes smaller. And what happens with the high energy environment sediment? Like, is it going to be at the exact same place as it was at the previous sea level? No, it's logical. You're right. As the sea level is changing, those sediment has to go after the sea level, because they always can only form in high energy shoreline environment if you're talking about, let's say, sand or pebbles. I hope you understand. So as the sea level is going up, that facies, the pebble facies, is moving with the sea level toward what? It's not going toward the deep water environment, because it represents a high energy environment. So logically, it's actually going toward the land. So this is what we call, the sediments are time regressive, I cannot say time transgressive. So don't worry if you cannot say it. We say it together a couple, time transgressive. So the sediments are time transgressive, meaning that their ages is vary from place to place. Because at the beginning of the sea level change, they were forming right here, but as the sea level started to increase, they moved toward the land, because the land has been shrinking now. So bigger and bigger area got covered by water. So time transgressive. And we call this the so-called transgressive facies pattern. And I left out a slide, so hopefully it's there. And yes, it is there. So I'm going to try to draw it with the mouse. It's not going to be easy, but okay. So here we are. Here is the land, and that's the sea level right here. And I even say sea level, well, just say SL and 1. So this here is the coarsest grained facies, and remember, we already learned the rock symbols. So if I draw pebbles, that's the highest energy environment. They're going to be right here. And then the sand, and then the silt, and then the clay. That's the deepest water environment. I think I can change the color here. No, I don't think so. No. Now, when the sea level is increasing, so here is sea level 2. Then what happens now? You got the pebbles right here. And then you got the sand right here. you got the silt here, and then the clay right here. And if the sea level goes up one more time, we just do 3. Now the pebbles are going to go even higher. And then you got the sand and the silt. And then the clay. So you end up with a sequence where the same type of sediment is moving toward the land. That's what we call time transgressive. So if you drill a borehole right here, what you will see is that you got, or right here, I didn't make a really good drawing, but what you have, if you look at that borehole, that you have pebbles on the bottom, and the pebbles are going to be followed by sand. If you don't understand, ask me in the lab to draw it for you, because this might be on the test. Gets followed by the silt and then the clay. So the grain size is actually getting smaller as you go up, and on top you're going to have clay, which is the deepest water sediment. So therefore the rocks which used to form in very, very shallow water are going to be covered with very deep water sediment. So you know the sea level went up. Okay, so this is transgression. And this here is a slide showing exactly the same thing. The brown sediment is going to be the sand, which is the highest energy. The yellow is, that might be pebble. This is sand. That's silt and clay, and this is limestone, which is the deepest water sediment. So here we are. If you look at the sea level changes, sea level is going up, and these sediments getting younger toward the land. You see how they're getting younger toward the land? And this is what we call transgression. The more landward are the deep water sediments, the more likely you have a transgression. The next one is the so-called regression. When you have a regression, everything is exactly opposite of the transgression. In that case, the continent actually getting bigger, so all the facies, the sedimentary facies, is moving toward the ocean. So the deeper water sediment in this case are going to be covered by shallower water sediment. So that's what's happening here. And this will produce a so-called regressive facies pattern, which is going to be really characterized by, as I just said, enlargement of land. So you're going to have more river, lake, and wind deposits. Like, you know, this is where you get those cross-buried dune deposits. You're going to have mud cracks because it's getting more land. And it's going to be truncated by unconformity because it becomes continent. The area which used to be covered with water is now becoming continent, so we're going to have an unconformity, and all the facies through time is shifting toward the ocean. So if you look at just one place, the sediment will be more coarse as you go up in time. So here is the place where I can draw it. So here you are, that's sea level. Now this is sea level 1. It's not very good, it's sea level. This wants to be SL. So here are the pebbles, sand, you got the silt right here, and then clay. Now sea level is going down, so this is sea level 2. This is 2. And now we got the pebbles here, the sand here, the silt, and the clay. Now the next sea level, pebbles are here. Sand, silt, and then clay. So if you drill a borehole right here, and we look at the section here, then you will see that the clay is covered by silt, covered by sand, and then it's covered by pebbles. So this is a coarsening upward or regressive facies pattern. So I will ask these drawings, and if you're in my distance learning classes, it's going to be on the midterm. I definitely will ask you that during the first two tests. Like, it's going to be on the first test. I'll ask questions, so you have to explain to me what's going on here. You might not be able to draw it, but you definitely have to explain all what I just did. I hope you understand. If not, ask me in the lab. And this just shows you the exact same thing. So here the different facies, if you look at through time, because this is time right here as time, the different facies are going toward the sea. And in lab, we're going to go through correlation, so you will actually work with this, and we're going to learn more about it as it goes on. And this takes us to the so-called Walter's law. And the Walter's law is talking about this guy Johannes Walter have figured out that instead of geologists walking the whole distance where the sedimentary basin used to be, to learn all the sedimentary facies, what kind of rocks are formed in that whole environment. Instead, as you can see, that you can see the different facies next to each other, but also if you drill a borehole, that shows every sediment through time which occurs next to each other. So if you know what kind of rocks do you have horizontally, all you have to do is just drill a borehole and see what kind of rocks are there vertically, because those are exactly the same rocks as they occur horizontally next to each other, just because of this facies pattern through sea level changes. So it's very interesting. That saved geologists from a lot of work, actually, at the time. Okay, I have to stop right here, and I will continue in the next segment.